Hello. Today we're going to go over skulls and the dental formula. These are ways of IDing species as well as sort of estimating what their diet was. As you may know, herbivores tend to have larger mast eaters. I probably mispronounced that. It's the muscles that connect to the lower jaw to help grind and open. If you see a horse's skeleton, right, they've got that really large flat area on their lower jaw, and that's where the masseter muscle attaches. Carnivores, on the other hand, tend to have a larger sagittal crest, which helps bite down the sagittal muscle attaches. You can also tell the difference between herbivores and carnivores based on their teeth. Carnivores tend to have more sharper teeth. They can actually have a modified molar called the casseries. If you've ever seen cat's teeth. Herbivores tend to have flat, larger molars, which help grind down plants. Zoom in on that. Now, the dental formula is quite important to ID a species. What is the dental formula, you might ask? It's an equation which tells you how many teeth they have in total, the skull has in total, as well as how many teeth you find on the upper jaw and the lower jaw. Now, the formula itself is incisors, canines, premolars, molars, and after each of these letters, so the incisors is I, canines C, premolars P, molars M, and after these there's a fraction. Now, the numerator is how many teeth there is on the upper jaw, but only half of the upper jaw. And the denominator is the number of teeth, only half of the number of teeth on the lower jaw. For example, the zebra. You can also use the horns to help you identify, especially in the antelope, which can be quite difficult to ID. You may still be confused. I've got a visual. I found this fox's skull a few months ago, about a month ago. There goes a premolar. The zygomatic arch, the auditory bulb, sometimes it can be more like shaky. Like if you look at the rat skull, they can move. And it's actually linked to their ability to hearing, so the more they move, apparently the better the hearing is, which might not be 100%. The incisors, I keep calling them incisors. The incisors, canine, premolar, molar. The difference between the premolar and molar can be kind of difficult, so you should have just have to guess. But if your skull has teeth in them, they're a bit easier to differentiate. Let's start with the fraction, the numerator. You split it in half. Count up here. We've got 3 incisors on the top. We've got 1 canine. We've got 1, 2, 3 premolars, and we've got 1, 2, 3 molars. On the lower jaw, which I managed to get, well, I only got half of it, which is enough to ID it. Canine, and then you have to sort of guess. I'm sort of guessing there's about 3 premolars here. 1, 2, that's probably connected somehow. 3, and then 1, 2, 3. I don't know why this molar is so small. Maybe it was a juvenile of some sort. Who knows? If you search up the dental formula for a fox, you've got 3 incisors from the top and the bottom, 1 canine from the top and the bottom, 4 premolars, 2 to 3 molars. I've counted wrong because that looks more like the others. So 1, 2, 3, 4 premolars. Because there's the 3 incisors and then the 2 molars. Incisors on the bottom. But of course, we've only got half. Don't really know what it's called, but like the front bit. So we're not 100% sure, but by the looks of it, it does look like a fox. And from where I found it, it's probably most likely a fox. I thought it was someone's dog, but then, yeah, I think it's most likely a fox. I mean, what do you guys think? I think it is a fox, because I'm also looking at my skull here, rat's skull, which rodents tend to have sharper and longer incisors, and then the gap between the incisors and the premolars and molars, that's called a diastema. You usually see in herbivores and omnivores. Diastema is there to help chew the food.